2, minimum operations to make columns strictly increasing. So we are given a m times n matrix grid consisting of non-negative integers, and in one operation, we can increase the value of any grid ij by 1. We're going to return the minimum number of operations needed to make all columns of a grid strictly increasing. Let's just check the first example. So for the first example, this is a 3. So in order to make the column increasing, we're going to make this number to be 4, and this number to be 5, and this number definitely, yeah, it's gonna be a 6. Yeah, and then we're gonna tag so here if it is a 4, we're gonna plus a 3. If this is 5, we're gonna plus a 2. If this is 6, we're gonna plus a 6. And for here 2, 3, 4, it is okay. And for this one, we're gonna use a 5. So this means we're gonna plus a 4. So the final answer is gonna be 15. Yeah, so we can directly solve it by using the brute force. So we're gonna check the let's just prepare a final result, and finally we're gonna return the result. So we're gonna check any columns. So for columns in let's say we're gonna use a zip star. Basically, in this way we can choose the column directly. So first of all, we're gonna star it. This means we're gonna star it. After star, we're gonna zip them together. So this means basically after the star, basically the array gonna become this kind of a situation, and we can zip them together. This means we're gonna choose the column one by one. Yeah, so first the star, and then we're gonna zip it. But for the column, it is a tuple. We need to turn the tuple into a list because we're gonna assign values to it in order to calculate the final result. So for I in range, we're gonna start from the second value in this column. So we need to have a tag. So if column I, so our current value is less than or equal to column I minus 1. So this means we need to update the final result. Let's just set it as a value. So for example, if this value 1 is less than 3, so this means we need to update the value to what? It's going to be column I minus 1 minus column I plus 1, because 1 is less than 3. So how many steps? It's going to be 3 minus 1 plus 1. It's going to be a 4. Yeah. So currently, so this means I minus 1, 3 minus 1, it is a 2, 2 plus 1, it's going to be 3. So this value means we need to increase a value of 3. Yeah, so this means we can directly put it to our result. But we need to update the column I, because currently this value is going to be 4. But how can we update it? It's going to be plus or equal to this value, because from beginning it is 1. Now we need to plus this value 3, so it's going to become 4. So finally, we just need to return the final result. Let me just run it and submit it to check if it works. As you can see, it works and it's pretty fast, and the time complexity is m times n. So according to the description, so mn going to be less than or equal to 50. Yeah, so the time complexity is going to be m times n, and the space complexity, let's say, so space complexity, because here we use some extra space, so for each of the column actually we use the sus column. We prepared all the column cases. I think the space complexity is going to be m times n as well. Definitely we used all the possible cases. Yeah, so for this column we used how many of them? It is the number of those, and the number of columns. We used all of them. Yeah, I think that's all about it. Thanks for watching. See you next